This video solves some of the problems at the end of the textbook, just to give you some examples of how the CAPM or security market line can be used in solving problems. So the first one I'm going to do is question 1 from chapter 13. And so it says, assume the following assets are correctly priced according to the security market line. The first question is derive the security market line. And the second is, what is the expected return on an asset with a beta of 2? So we're given this information. We're given the expected returns for each asset and their betas, and we're trying to find what is the security market line. So first of all, we know this is the equation for the security market line, and we have to come up with, we don't know what's RF, we don't know what's RM bar, so we need to come up with those two values, and here's how we do it. So we have some components, we have R1 bar and we have beta 1. We'll try to use that to come up with what we need. Okay, so if we just write down for asset 1, what's the equation? So let's just write asset 1. We'd have 6 equals RF plus 0.5, times RM minus RF. Okay, and asset 2, we'd have 12 equals RF plus 0, now it's 1.5 times RM minus RF. So just to explain what I did here, 6 is the expected return for asset 1. That's why it's 6. Okay, RF we don't know. We don't know what's RM minus RF, but we do know what's beta for asset 1. That's 0.5. Okay, so when I write it that way, it's 6 equals RF plus 0.5 times RM minus RF. The second asset, the expected return is 12, and its beta is 1.5, so that's the value there. We can call this equation 1. We can call this equation 2. And now we have to somehow find what's RF, and we have to find what's RM basically. Oh, actually this should be RM bar, right? Not just RM. Okay, so the first thing we can notice is if we just subtract these two equations, if we subtract these things, the RFs go away and we'll just be left with some term. So we'll do that to sort of simplify our problems. Okay, so we'll do equation 2 minus equation 1 and see what that gives us. So we'd have 12 minus 6, which gives us the left side as 6 equals, okay, we'd have RF minus RF, so that's 0, so we don't care about that. That's cancel away. That's the whole point we started this in the first place. And now here's something we can think. We have 1.5 times this value, 1.5 times this value minus 0.5 of the same value. Okay, so if we subtract that away, we'd just be left with 1.5 minus 0.5, which is 1 times that same value. Okay, and then that leaves us with a sum equation which says that RM bar minus RF is equal to 6. So we've somewhat simplified this. We can call this equation 3. Okay, now we'll take this equation, we'll take equation 3 and plug it into equation 1, just so that we can eliminate some of the terms. So we have, now we'll plug 3 in 1. What do we get? So we had 6 on the left side, that did not change. We have equals RF, that did not change. We know what's beta is still 0.5. But now we know what's this term. We know that this whole RM minus RF term, we just found it to be 6. So times 6. Okay, which leaves us with 6 equals RF plus 0.5 times 6 is 3. So that gives RF equals 6 minus 3, which is 3. Now we can plug this value into any of the other equations. So we already know that RM bar minus RF is equal to, here is 6, right? And now we know what's RF. So we have RM bar is equal to 6 plus RF. And we just calculated what's RF. RF is equal to 3. So you have RM bar is equal to 6 plus 3, which is equal to 9. So our security market line now is what? Is RF, which is 3 plus, we have to write the left-hand side first. RI bar is equal to 3 plus beta I times whatever RM minus RF is. RM minus RF is 6. Or let me write it with the... Okay, that is our security market line. Hopefully that's clear. Hopefully you understand where this came from. This 6 is just the RM minus RF. So I plugged in all the values, into this equation here. Okay, RM minus RF is 6. RF is, we just calculated to be 3. And so we can plug that in. Now, the question also asks, what is the expected return on an asset with beta equals 2? So when beta equals 2, we just plug in 2 for this equation and find out what it is. Okay, so I'll write beta equals 2 gives RI bar is equal to 3 plus 2 times 6. Okay, 2 times 6 is 12. 12 plus 3 is 15. So you have RI bar equals 15. That's the end of that problem. The next problem I'd like to solve for you is problem 3, just to give you a little other kind of problem. So it gives us two funds. Okay, it gives us an actual return and a beta for fund A and fund B. It gives us the security market line and tells us to find out what we can say about the fund performance. Okay, so let me just write down some of the stuff we have. We have fund A. The true performance, the actual return is 10%, and beta for asset A, for fund A, is 0.8. The actual return for fund B, is 15%. The beta for fund B is 1.2%. And we're given a security market line. We have RI bar is equal to 0.06 plus 0.19 times beta I. So basically, the problem solving strategy here is we're going to compare, so we know that this is the true performance that we should have. Okay, this is the security market line. This is with CAPM. If we plug in our beta, we should get some return. Okay, and we're going to see how does that true return that we should have got, how does that compare to the actual return. If our return is more than, if the actual return here is more than what we should be getting in the true model, that means this fund is doing good. Okay, if this actual return is less than what we should be getting, that fund is actually doing bad. So let's look at it. Okay, RA bar. So we're gonna find what is our fund performance for RA first. RA bar. If we plug in our beta of 0.8, what do we get? We just get 0.06 plus 0.19 times 0.8. If you do that calculation, you should be getting 0.212, which is 21.2%. So we can already see this number is much bigger than this. Okay, so we were expecting 21.2%, or we should have gotten 21.2%, but the fund actually got only 10%. And so we can already see that fund A is not doing good. Okay, fund A is done much worse than we thought. Let's look at what happens for fund B. We have 0.06 plus 0.19 times its beta, which is 1.2. That turns out to be 0.288, which is 28.8%. Okay, again, we can see we should have gotten at least 28.8%, but we're only getting 15%. So both our actual returns are less than our expected returns, or what we should be getting using the model. So both these funds have actually performed bad. Okay, I'll write that down just so it's 100% clear what's going on. Actual return for both funds are less than what is expected when using the SML, the security market line. So both funds performed worse than expected. So once again, the problem-solving strategy is do what? Use this model to find out what the return should have been, and then compare with what the return actually turned out to be. If let's say if we had gotten this value to be 9%, let's say our A bar was supposed to be 9% and our actual return was 10%, this fund would actually perform better than what we expected. However, we find that we should have gotten 21.2%, but we only got 10%, so fund A performed worse than it should have. We should have gotten 28.8% for B, but we only got 15, so fund B also performed worse than it should have.